Hello and welcome, dear learners, once again to Mathlete Minds. As we continue our journey of trigonometry, we invite you to join us in exploring the beauty and utility of the timeless mathematical constructs called as trigonometric identities. But before we proceed to solve questions and see the applications of these identities, may I sincerely request each one of you to kindly like, share, and subscribe to the channel as much as possible. Moving on, we'll take up the questions pertaining to the three identities that is there in the syllabus of class 10. Now, in the previous video, we had done very simple questions based on those three identities. In this particular video, we'll take slightly advanced level questions over here, and these are also in the same syllabus of CBSE. Now, let's see what are these questions over here and how we apply these identities in the various formats and solve these questions over here. So the first one over here is given as 1 by cosec A minus cot A minus 1 by sin A is equal to 1 by sin A minus 1 by cosec A plus cot A. So we state the left hand side over here and rewrite this as 1 by, this is cosec A minus cot A, and 1 by sin A can be written as cosec A. Now this portion over here, the extreme, this left hand term over here, we can multiply and divide it by cosec A plus cot A, and the denominator becomes cosec square A minus cot square A using the identity A minus B into A plus B. Now again, if we apply the identity cosec square A minus cot square A is equal to 1, the denominator becomes cosec A plus cot A, this is 1, and we are left with these terms over here. Now from here we can proceed in two different ways. We can cancel out the cosec A terms and leave it as cot A and take the right hand side and reduce that also to cot A and say that the left hand side is equal to right hand side. Otherwise, we can also do it this way. We can take this terms this way and rewrite them as minus, put this inside the bracket, cosec A minus cot A. So now cosec A is over here, and this term will multiply and divide by cosec A plus cot A. So this becomes cosec A plus cot A into cosec A minus cot A divided by cosec A minus cot A. So now this numerator becomes cosec square A minus cot square A, that is 1, and we are left with cosec A minus 1 by cosec A plus cot A. Cosec A plus cot A. So this is equal to cosec A is 1 by sin A minus 1 by cosec A plus cot A. So this is the right hand side which was to be proved. So this way we can prove this. Moving on, the next question that we have is tan A by 1 minus cot A plus cot A by 1 minus tan A is equal to 1 plus tan A plus cot A is equal to 1 plus sec A into cosec A. Now these questions can be done in different ways. You can simplify them in sine and cos terms and also proceed. Here I am going to take the extreme left expression over here and keep it as tan and cot. So this term over here, tan A, this cot A I'll change to 1 by tan A. Plus cot A again in the numerator, we'll convert this into tan A by 1 minus tan A. So here if we take the LCM in the denominator, we get this expression as tan square A by tan A minus 1 plus 1 by tan A into 1 minus tan A. Now this is a crucial step over here. We'll take out minus common. How we'll take out minus common in the second term? This is tan A. This comes down as it is. Take out minus common, so this plus becomes minus. We are left with tan A into tan A minus 1. Now take the LCM. The LCM will be tan A into tan A minus 1. So this numerator becomes tan cube A minus 1. Now expand this using a cube minus b cube. So we get here tan a minus 1 into tan squared a plus tan a plus 1 divided by tan a into tan a minus 1. So this and this term get cancelled. Now divide each of these terms by tan a. So we are left with tan a plus 1 plus cot a. Now this is the middle one over here. Now proceeding with this one, we'll get the right hand side also, extreme right hand side also. So we get over here, this is 1 plus tan a plus cot a. Now we'll convert this into sine and cos. So 1 plus sine a by cos a plus cos a by sine a. Keep this one apart and take the LCM. So this becomes cos a into sine a. This becomes sine square a plus cos square a. So the numerator becomes 1 plus 1 by cos a into sine a. Now cos a, 1 by cos a is sec a, so we get here 1 by sec a, and 1 by sine a is cosec a, so 1 plus sec a into cosec a, which was the extreme right expression over there. Next question is, if sine theta plus sine square theta is 1, then prove that cos square theta plus cos square theta is 1. So here again, see the different way in which we work out these sums. We take the sine theta plus sine square theta is equal to 1 and rewrite this as sine theta is equal to 1 minus sine square theta. So sine theta becomes equal to cos square theta. Now we take this expression that is asked to be proved and we rewrite this as cos square theta. This is cos 4 theta. So this can be written as cos square theta plus cos square theta whole square. Now this becomes equal to cos square theta plus sine square theta, that is equal to 1. Cos square theta is sine theta, so this becomes sine square theta. So see how this has been applied in a different manner over here. Next question is, a cos theta minus b sine theta is c. Prove that a sine theta plus b cos theta is root over a square plus b square minus c square plus 1. So what we do is we take this given term expression or the equation and square both the sides. Square both the sides. So this becomes equal to a square cos square theta plus b square sine square theta minus 2ab cos theta sine theta. And the right hand side is c square. Now here we have to get sine theta and cos a sine theta. So we'll break this cos square theta as 1 minus sine square theta. And we'll break the sine square theta as 1 minus cos square theta. Minus 2ab sine theta cos theta is equal to c square. So now open up the bracket. You get a square minus a square sine square theta plus b square minus b square cos square theta minus 2ab sine theta cos theta is equal to c square. Now we'll transfer the term. We'll keep a square plus b square and bring c square to the left hand side. Transfer the remaining terms to the right hand side. So we get here a square sine square theta plus b square cos square theta plus 2ab sine theta cos theta. So this becomes equal to, bring down this as it is, and this can be compiled as a sine theta plus b cos theta whole square. So this is equal to a sine theta plus b cos theta. The value of this will be, you take the square root of the left hand side. So this is equal to a square plus b square minus c square. So this is what we have to prove over here. Next question is, tan theta plus sine theta is n and tan theta minus sine theta is n. Then show that n square minus n square is 4 root mn. So this can also be done in different ways. I'll start from here. M squared minus n squared. Now what is m squared minus n squared equal to? This will be equal to tan theta plus sine theta whole square minus tan theta minus sine theta the whole square. So this becomes, expand this using a square, a plus b the whole square. We get here plus sine square theta plus 2 tan theta into sine theta. And this is minus here, so the signs will change. We'll get here minus tan square theta minus sine square theta plus 2 tan theta into sine theta. So now the terms will get cancelled. These two terms will get cancelled over here. We are left with 4 tan theta into sine theta. So now this can be written as 4 under root tan square theta into sine square theta. This is equal to this. So now we can rewrite this tan square theta as sine square theta by cos square theta into sine square theta. Next step, we can break this up. Sine square theta as 1 minus cos square theta into sine square theta by cos square theta. So here if we separate the terms, we'll get over here 4 outside the bracket, and we'll get here sine square theta by cos square theta into 1, that is tan square theta, minus cos square theta by cos square theta into sine square theta, that is equal to sine square theta. So again we'll apply here a squared minus b squared. We'll get here 4 into tan theta plus sine theta into tan theta minus sine theta. So this is equal to 4 root over m into n. Now here this can be left till here, and the right hand side, that is 4 root mn, can be brought to this particular expression. So that can also be done. There is no hard and fast rule that you have to take the left hand side and ultimately bring it to the right hand side. The next question is, prove that tan theta plus sec theta minus 1 by tan theta minus sec theta plus 1 is equal to 1 plus sine theta by cos theta. Now here we take the left hand side, tan theta plus sec theta minus 1 by tan theta minus sec theta plus 1. Now here we must take note of the right hand side. The right hand side, if you separate the terms, you get here sec theta plus cosec theta, which comes in the numerator. So this you must keep in mind. This comes in the numerator when you separate the term. So here what we are going to do is, in the next step, we will be replacing this 1 with sec square theta minus tan square theta. We need a term in the numerator over here. The right hand side is in the numerator, so the 1 in the numerator has been replaced. The denominator 1, we'll keep it as it is. Tan theta minus sec theta plus 1. So this becomes, now this is a plus b into a minus b, so we can take out sec theta plus tan theta common from this term, and we are left here with 1 minus sec theta minus tan theta divided by the denominator continues as it is. No need to do anything with the denominator. So now if we open up the bracket in the numerator, we'll get here sec theta plus tan theta continues as it is, and the second term, this will become 1 minus sec theta plus tan theta, and in the denominator also we have 1 minus sec theta plus tan theta. So now you see these two terms get cancelled, and we are left with sec theta plus tan theta. So sec theta is equal to 1 by cos theta, and tan theta is sine theta by cos theta. So we get over here 1 plus sine theta by cos theta. So the things that you need to keep in mind are where you have to convert 1 into the given identity. So that needs to be understood thoroughly. Next question is sec theta plus tan theta is p. Show that p squared minus 1 by p squared plus 1 is equal to sine theta. So this question can also be done in different ways. I'll proceed by taking p squared minus 1 by p squared plus 1, the left hand side of this term, and replace this p square with sec theta plus tan theta, the whole square. And here in this question, we will be replacing both the numerator and the denominator with sec square theta minus tan square theta. Keep this in the bracket so that there is no error in the sign. Denominator will be sec theta plus tan theta whole square plus sec square theta minus tan square theta. Now what we do is, you can either take out sec theta plus tan theta common and proceed, or we can even expand this using a plus b the whole square. So we get here sec square theta plus tan square theta plus 2 sec theta into tan theta minus sec square theta plus tan square theta divided by sec square theta plus tan square theta plus 2 sec theta tan theta plus sec square theta minus tan square theta. So in the numerator, the sec square theta term gets cancelled. In the denominator, the tan square theta terms gets cancelled. So in the numerator, we are getting 2 tan square theta plus 2 sec theta into tan theta. And in the denominator, we are getting 2 sec square theta plus 2 sec theta into tan theta. So from the numerator, we can take out 2 tan theta common, and we are left with tan theta plus sec theta. And in the denominator, we take out 2 sec theta common, and we are left with sec theta plus tan theta. So basically these two terms are same, we cancel out, and now this 2 and 2 can also be cancelled, and tan theta by sec theta. So if you simplify, put them in the form of sine and cos, you will be left with sine theta, which is the right hand side. You can even proceed from here. Sec theta plus tan theta is equal to p. You can take the identity sec square theta minus tan square theta and proceed from there. That is also one option over here. Next question is cos theta plus sine theta is root 2 cos theta. Then show that cos theta minus sine theta is root 2 sine theta. So here in this, we start from what is the given fact or data. Cos theta plus sine theta is equal to root 2 cos theta. So here we will square this given fact in both the sides. So squaring both the sides, we'll get here cos square theta plus sine square theta plus 2 cos theta into sine theta is equal to 2 cos square theta. Now, next step what we do is we rewrite this as sine square theta plus 2 cos theta into sine theta is equal to cos square theta. This cos square theta subtracted from this cos square theta, you are left with cos square theta. Here, if we are not going to write this as 1, so that must be kept in mind. Second, next step is we'll rewrite this as sine square theta is equal to cos square theta minus 2 cos theta into sine theta. And since we have to get here cos theta minus sine theta, we will add sine square theta on both the sides. This is an equation, so we can add a term on both the sides. So we get here cos square theta minus 2 cos theta into sine theta plus sine square theta. So the right hand side becomes cos theta minus sine theta the whole square using a minus b the whole square. So this is equal to 2 sine square theta. So this becomes cos theta minus sine theta is equal to, taking the square root 2 sine theta, which is to be proved. Next question is, if sec theta is x plus 1 by 4x, prove that sec theta plus tan theta is 2x or 1 by 2x. Now here we need to get the value of tan theta. Now this question again, supposing you do it as 1 by cos theta is x plus 4 or 1 by 4x and find the value of sine and cos with the help of Pythagoras theorem. It can be done that way also, but it will be pretty lengthy. So what we are going to do is we will take the help of the identity over here, and we will write here sec square theta minus 1 is equal to tan square theta, the second identity. So now replacing sec square theta by x plus 1 by 4x the whole square minus 1, this is equal to tan square theta. So this becomes equal to x square plus 1 by 16x square plus 2 into x into 1 by 4x minus 1 is equal to tan square theta. So now this x and x will get cancelled, 2 and this 4 we can cancel out, and we are left with x square plus 1 by 16x square. Now this is half minus 1, that is minus half, is equal to tan square theta. So now this can be written as x square plus 1 by 16x square. We can multiply this half by 2x and at the same time divide it also by 2x, so we'll get here 4x. Alright, this multiplying and dividing by 2x and 2x. So this is equal to tan square theta. Now this becomes 2 into x into 1 by 4x, as we had got over here 2 into x into 1 by 4x. So this can be compiled as x minus 1 by x minus 1 by x minus 1 by 4x the whole square is equal to tan square theta. So tan theta will be equal to plus minus x minus 1 by 4x. Now if we take the plus sign and add it with the value of sec theta, so we'll get here x plus 1 by 4x plus x by minus 1 by 4x, that is equal to 2x. And if we take the negative sign, we'll get 2 by 4x, x plus 1 by 4x minus x plus 1 by 4x, we'll get here 2 by 4x, that is equal to 1 by 2x. So that is what has to be proved away. So here in this way it becomes simpler. Do not struggle with finding the value of tan with help of sine and cos and everything. That will be a bit too lengthy. Next question is x by a cos theta plus y by b sine theta is 1 and x by a sine theta minus y by b cos theta is equal to 1. Prove that x square by a square plus y square by b square is 2. So here it's very simple in this question. You square both these expressions given and simply add them up. So if I take the first one and square it, I'll get here x square by a square plus y square, cos square theta plus y square by b square sine square theta plus 2x by a into y by b cos theta sine theta is equal to 1. 1 if it is squared, we get 1. The second expression becomes x squared by a square sine square theta plus y square by b square cos square theta minus 2x by a into y by b cos theta sine theta is equal to 1. Now add them up. This term gets cancelled. 1 is plus, 1 is minus. If you add these two terms, this is cos square theta here. Take out x squared by a square common. Cos square theta plus sine square theta is 1. Here also take out y squared by b square common. Sine square theta plus cos square theta is 1. 1 plus 1 is 2. So this is what has to be proved. So simply squaring and adding, we get this. So you can see in so many different ways we have applied the same three identities and got the desired result. So basically, all these questions, like when you solve them, you need to keep in mind as to what is the best tactical approach over there. Always converting everything into sec theta, sine theta, cos theta and solving makes it a bit tedious and a bit lengthy. Hope you like the explanation. Kindly like, share and subscribe to the channel. Thank you for watching.